So this is the register function, and it's pretty small. There's not a lot to it, but let's just take a look at the structure of this function. So I'll just and this is exactly the same code. I just copied it over. If you see here in the public, the function is public, so we can access it from outside the canister, and we made it a shared function. And if you see, we have a message here, and what this does is that we are saying to whoever is calling this register function that we would like to get an identifier for our function, so we can see who's making this call. And that's what we use. We send this caller identification with the request from the front end, so we can see who it is who's making the request. So this is actually the only way you need to tell the application or the functions who it is that's calling it. You just add the shared message to your function, and then you can use that for your user identification. If you see here, usually we just say we want the result to be, we want to return, let's say we want to return a number, or we want to return a string. Another option we have is that we can also make it a little bit more granular. We can say, okay, we got a result that was a success, or we got an error. In this case, if the register function is run successfully, we actually want to have the player's details returned, and if it's not a success, then we want to return an error message. So that's what this result does. It looks in the code for a success or an error, and if we go down to the switch here, what we do here, if we look up in the lines that's let player ID equals message caller, that access the principal ID of the owner of the call that made it from the front end, and we make a lookup to see if there's a player, and if the player is valid. And in this switch, we just say, okay, if we have a player, we can update our array of recent players, and we return an OK. This hash OK is saying, okay, this was successful, and therefore we return the player view. If we go further down and see if it's not a valid name, we return a hash error, and then we return an error code saying invalid name. And there's also a check if the name already exists. So let's say my name had already been used, then we say, okay, you can't create a user with that name, and then we return another error message. If we go and look at how we implement that in the front end, then we can go to the code again. In here, in the assets canister, we have all the files. We have the assets, and here we have an index file. This is where everything is set up, where we have the basic functionality. And here we start by, let's see, we start by including the DFINITY JavaScript agent, and there's a couple of imports here. One is that we want to use our identity function, and that's one where we want to connect to an actor, and we want to use the agent's functionality to manage these requests. And let's go back here, and here you see this is just the basic setup we have already. We saw in the code. We also set up we want to get the canister ID, and we want to get the ideal factory, and we can access all that from our candidate, and the agent is taking care of the rest of it. Okay, so from the register function, we already specified that we wanted to have an identity provided when we make a call. So we use the key identity function from our agent to create this identity, and then we store it in local storage in the browser. So this is just for the front end. We want to keep that. The user ID, so we can use that and send that and associate that with our calls. And here we have another function that reads identity, and if the identity is not existing already, then we just create it. And we can go back to the code and see it's exactly the same we have here. Okay, so now the identity part is established. So now when we want to make a call, we can associate an identity with this call. We first establish an agent, and we use the DFINITY agent, JavaScript agent, and we create an agent with the identity as a parameter. We want to use this identity every time we make a request using the agent. Then we want to set up a connection to the actor, and if you remember from the last presentation, if you went to that, when we go to our Motoko, all the functionality we have is encapsulated in an actor. So we want to connect to this actor. So every function that is public, is made public in this actor, we can access this as soon as we have connected to it in our front end. So that's what we do. That's what we do with this create actor. We create a new instance, and we use the agent that we already created, which holds the identity of our user here, and we provide the canister ID. And let's see, and we do the same for the assets canister. So if we want to directly access content, or if we want to access resources that is in the asset canister, we can easily call them too. Okay, so this is how we in the front end can register a new user for a game. And this one takes the player name, which we are providing, or which we're getting from the UI. There's if you remember, there was an input field where you can say, this is my name, and this, I want to play a game. So we take that player name and we call the register function. This function will either return successfully, and then we do some work with that, or it fails, which we hopefully won't experience, but we can handle that as well. If we go back to the code for a minute. We can see what we're actually doing is when we register when it's successful, we add it to a list of registered players. The front end didn't show it, but if there is a list of players who's already signed up and active, let's say you want to play against one who's already on here, then you can pick from that list. So we need to keep a record of who's actually recently played and who's currently playing. Okay, and let's see. And then actually, I want to go back. Let's go back to the code. As we're doing pretty well on time. Just make this bigger. Okay. So that was the register flow, and we have a similar flow for start. Let's find that. So here we have the function that will start the game. And again, here, because we already provide who we are when we are calling this function, because we provide our identity, all we need is to provide the name of the opponent. Just like the results, just like the response we wanted to return with the register. Here we want to return a game view, and if we can't connect to a user, then we want to throw an error or show an error message. Again, here we get the caller ID, the ID of the one who's making the request here, and this is the format of the caller is principal, and you can look that up in our documentation as well. We describe how the principal and how our user IDs are structured. But otherwise, we'll look up a game and see if there's a player by this ID that we provided, and then we will see if there's an opponent with the name that we provided that we want to play. And then we have some error handling in case this person is not existing. Otherwise, we will wait for that player to join. If the player is not joining, then we will time out and just choose the next one that comes along. I want to talk a little bit about, and we didn't mention that so far, the way that we are saving the interactions and saving the users, and we are registering the players. With the Internet Computer, the state is always saved. There's a difference though. In this case, we want to save the accounts. So if I have registered myself as a player, I want that information to be persistent. Even if I go and upload a new version of the code to the canister, I want that state, I want that information to be persistent, and we can do that by declaring a variable as stable. This means that we can update the software in the canister. We can do whatever we want to it. We will always we'll always save the state of this variable. So if you see, there is also here, we have a function we call here that if we are going to upgrade our canister software, we want to make sure that we save the accounts. So we take this accounts that we use in our game, and we store that to accounts underscore v2, and we can then reload that later when we want to load all our accounts. We take whatever we have in accounts v2 plus whatever we added through the game in its current state. So if you want to keep data persistent, even surviving an complete upgrade of the software, then we have a way to assign the variable as stable, and it'll keep its state no matter what we do to it. Okay, let's see. I think I'll actually stop here. Last time we didn't really have a lot of questions. We didn't have a lot of time for that, so I actually think we should spend some time. Maybe if someone has a question about something that I went through, and then spend some time on that. How do you feel about that, Daniel?
Yes, that sounds perfect. So I guess to anyone here watching, if you have any questions here at the moment, feel free to throw those in chat and we'll get those answered for you.
And if there aren't any immediate questions that come to mind, Carsten wasn't sure if there's more stuff you wanted to go over, because sometimes I think people might have questions in context of something that's being explained. Okay, we do actually have a question in the chat now. It's not specifically related to the game, So the question is, what would be the best way to build a social media platform in Motoko, of which there are several examples on the IC, like Discover or like District?
I'm not sure if I understand the question.
I think maybe they're thinking through like, how would you architect it? Like, what are the different canisters that would exist? How would that be written in Motoko?
Yeah. So I think a good way to look at it is, when we're talking about a social, I can just if we look at, I just want to go and open this one. So this is a very simple application. I only have two canisters. I have one for the backend and one for the front end. I think when you're starting to build bigger applications like a social media platform, or even maybe not something as big, but when your code starts to grow and your functionality starts to grow, I actually like to split the code into canisters that has a certain purpose. So let's say you have users. You have a lot of functionality around users. You can create users, update users. Maybe you can associate articles or posts, or you can maybe have some images, the profile images. I think taking that user functionality and separate that out and create one canister for that. The same, let's say you have some other functionality. It could be a certain feature of your app that makes sense to break that down. I would break it down to and create canisters for that. So a lot of the applications we see that people are building on the IC that grow bigger and bigger, that we see a clear sign that they split it up into the functionalities and create separate canisters for that. We can easily make calls between different canisters. So even though it sounds like you're separating, you're splitting up your application in many parts, the inter-canister communication is super fast and easy to do. So it doesn't matter if your user functionality is in one canister and maybe you're rendering your front end in another canister. It's very easy to have that inter-canister communication. And there's also a limit. Right now, I think the limit we support is 4 GB of memory in the canister. It's something we are expanding. We have taken the first steps to grow that, but that also means that if you have a lot of images, then you can easily run out of space in one canister, and then you can break it up into more canisters. We have some examples of a video sharing platform where the creator of the platform has a dynamic way of creating new canisters, and they just create more canisters and fill them up as they go to kind of get around the maximum limit size of the canisters. Those sizes are getting increased now, but you can still end up in a situation where it makes sense to look at the amount of data you have and then have use canisters for storage and split it up into multiple canisters and build some logic around that. So as an application grows, there are some things you can do to make your application scale based on the current canister sizes we have. So I think there's two things that I would take into consideration if I was going to build a big application. One, think about if I can split my application up into smaller chunks and have canisters that handle specific functionalities. And then how do I deal with if my data grows do I build a way where I can spread my data over multiple canisters, or can I still fit it inside one canister? I think there's two things, two design considerations that I would definitely work on.
Cool, thanks, Carsten. We got another question in the chat. So where is the data stored? For example, if you're building a game, there's player data, or if you're uploading an image data, is it stored directly in the canister?
Yeah, it is. It is stored in the canister's memory.
Cool. Hope that clarified the question for the person who asked this. And another question from the chat.
And just to add a little bit to that answer. When I was talking about the stable memory versus the regular memory, when you're storing data in the canister, we do have a method to make sure that even though it's in the canister, that when you upgrade the canister, then that data can still be persistent, that data can still be secure, and I'll definitely recommend reading up on how that method works, because if you don't make your storage stable, then it will be wiped next time you run an upgrade.
Great. So another question from the chat. Can you show us loops or recursive code in Motoko?
Here we have a for loop. It's really not that different from most popular programming languages. In this case, we used for, but you can also iterate over an array or what you like. Yeah, this is very similar to how you would do it in like JavaScript and other programming languages. There's not a huge difference here.
Awesome. I think those were the questions for now in the chat. So Carsten, if you wanted to continue walking us through reverse A or any sort of best practices, I'm sure additional questions will emerge.
Yeah. Actually, we can try to go further into. I would say this game is actually a pretty good example of how you can build applications in Motoko. So I would actually recommend that you go to the repo. I can find that again. Let's see.
And while you're copying the important links into the chat, there is another question from one of the participants here. So just to clarify, if every user of the platform gets one canister for the user account, it means every user only has 4 GB of storage space?
You can create as many canisters as you want. That's completely up to you how many canisters you want to deploy. Some applications spans over many canisters. So yeah, there's a limitation per canister, but you can deploy as many canisters and spread your data over as many canisters as you want. So the limitation is only really per canister, but since you can deploy as many canisters as you want, you can also store as much data as you want. So I would say that the limitation is on the individual canister, but you're not limited to only deploying one canister. You can deploy as many as you want.
Great. I think that was helpful for the person who asked this question.
Okay,
Thanks,
great.
Carsten.
So I just want to maybe walk a little bit through the application here, if you want to explore that on your own. So the game, we have the main file here, and we've already walked through a little bit. There's the accounts, how you get all the accounts, and we walked through the register, and then talked a little bit about, let's see. Yeah, about the start. So I would say that those two are good starting points. There is a lot of functionality that is about the game and how the game works, and that's all in the game that Motoko file. And here is like how you initialize the board, how you render the board, and all that, and all these functionalities that supports running the game, including if you want to see if a given color exists, or if there's one of these round symbols already on the board. And the great thing about this application is that there's actually a lot of inline description here. So it shows really what the different functions do. So I think it's very good for learning for learning how this game really works. One thing I haven't talked about, and I think this is good practice as well, is that your special types, like if we go and see earlier, we had we returned the play view. All of these types, we separate that out in a file called types.mo. So we can define not only like more simple types, like the player ID is a principal, and the principal is following the Motoko format, but also you can define your own types that you use throughout the application, and separating them out and calling this file from your main file. It gives it a lot better structure. It's a lot easier to navigate. A good example, if you want to look at the game view here, this is one way we can return if the game is started successfully. Then we can go and take a look at the types here and see this is an object we create that holds a dimension. That means for the size of the board and the board name and the different moves that we have made already, and keep track of the state of the game in this game view, and use this to render the view. So really think about how you're using the different types, both the types that are provided by the Motoko language, but also the types that you can define yourself. I think this game really shows how you can use your own custom types. I think that's a lot of good examples of that in this. In this game, we also have utility. This features that you call from throughout the application. It's something that's not really like the main functionality, but more supporting the functionalities separated out into a utility. And I think this is pretty much how most applications I see how they are laid out. That you have a main file. This is where you have your main functionality. You have your types, where you define your types that you use in the application. And then if you have some supporting functionality, keep them in utility. I think that's a very common way to structure your files, and that's also why this is a good example. If you go down and look at the assets files, which means this is the HTML and the JavaScript. Everything that's in the asset folder here will also be copied over and to the canister. So in this case, like the MP3 file that we play every time we make a move, you can place that in the assets folder, and then you can, from your front end, directly access this. I think it's in here. Yeah, load the sound. We just get it from the root of our canister. So very easy to add front end resources and files to the canisters as well. Yeah, I don't know if I have anything else to add to this project. As I mentioned, this is running locally, so you can see your your canister IDs from here. And we can actually, if we just want to test our backend, I showed that briefly in our last session. Let's see. Oh, you can also test that. Let's see. What I'm doing here is in the local canister IDs here, I get a candid canister as well, and I want to see my backend, so I provide that here. And here, all the functions that we saw is also available as an easy way to test. Let's say I want to register. I don't know if that has already been dropped. Okay, so after some time, the user accounts is being dropped, because otherwise the list would grow pretty big. And I see mine was already dropped. So from the candid interface here, I can use the backend functions as well. I can use that for testing. That's a lot of times that's really convenient. And let's say I want to play someone else. I want to play Brian. We should be able to set up a new game. And yes, it seemed like that was working. So yeah, that's another thing. I like to use the candid UI when I'm working on the back end and develop back end functionalities, because it's typically easier to test either using the candid UI or making direct canister calls. But the candid UI is really easy, and it's provided as a canister when you run it when you build your application. So it's very easy to use. Yeah, I don't know if there's any more questions.
Yes, feel free to ask any final questions you may have here in the chat. We'll be sure to get those answered. But in the meantime, Carsten, thank you so much for another great presentation here as part of the technical workshops, the Internet Computer Hackathon. And thank you so much to Elizabeth for assisting with those questions in the chat as well. Any of these slides in this recording, as well as any useful GitHub links to the code, will be uploaded to our Medium page and YouTube here within the next day. I believe Anupam will pop those links here into the chat in just a moment. And stay tuned here over the next couple of days on Twitter and Discord for any updates about any upcoming workshops within the Internet Computer Hackathon, as well as just within the Encode community universe as well. But if nothing else here, we should be good to go ahead and wrap up. But again, Carsten, thank you so much for the great workshop again.
Yeah, thank you.
Yeah, thank you. And everyone have a great rest of your evening, morning, afternoon, wherever you may be located. See you.